Hey y'all, Adam the Exacto Guru here, and today I'm going to talk to you a bit about a topic I'm pretty passionate about. As a power engineer, electricity, and in particular how we generate that electricity, is something I care quite deeply about. I'm talking about nuclear power, and I hope you'll bear with me. Nuclear power is generated by colliding neutrons into atoms, which causes the atoms to split and release more neutrons, which collide with more atoms and causes a continuing chain reaction. This generates heat, which is absorbed by water and converted to steam. That steam is then used to spin a turbine connected to a generator. The turbine spins the generator, producing electricity. The problem most opponents to nuclear power point to, aside from accidents, is the waste, or spent fuel rods. These rods are considered depleted as they are no longer able to support the chain reaction in most thermal reactors. However, CANDU is working to develop a Gen 4 reactor, which will be able to use these spent rods by splitting the remaining isotopes further. The aim of this is to help reduce the amount of nuclear waste currently sitting in storage. This storage is the area where people really take issue with nuclear waste. However, those same people fail to understand that the scientists and engineers involved in these projects are even more concerned about a possible leak than the average person. The containers for the spent fuel rods are subjected to regular endurance testing. Tests which are constantly being redesigned to push the limits of these containers. Those tests include such extremes as being dropped from great heights, being slammed into a wall at high speed, being dropped onto a puncture point, and being left in burning jet fuel for multiple hours. So far, no single container used by governments in North America has suffered a single leak in field service. To further ensure the safety of these already insanely tough containers, nuclear energy authorities choose storage sites that are geologically stable. If you don't believe this, think of it this way. These people have much more to lose from there being a release of nuclear waste than you or I. They would likely be fired from their current job, unable to get hired on with a new company because of the incident, which would be highly publicized and humiliating on a personal level. These people's entire lives would be utterly destroyed by this one mistake, a mistake which would likely cost human lives and rest upon their conscience until they drew their last breath. The other objection opponents to nuclear power raise is the risk of accidents, usually citing examples such as Fukushima, Chernobyl, and 3 Mile Island. The problem here is that there are underlying details which contributed to these disasters, outside of the inherent risks associated with nuclear power itself. I feel it is best to touch on each of these disasters individually in order to pay them the respect they deserved. In regards to Fukushima, a number of factors were against the facility in the first place. The plant failed to shut down automatically, continuing to operate an hour after the earthquake, when the other nuclear facilities in the region had all shut down safely. This speaks to operator or owner error. Either the operators in the plant failed to see that their equipment was not functioning properly, or the owner of the plant neglected to replace the required parts when the issue was raised. The other major factor was the construction of the plant itself. It was under-equipped for the region, only having pumping capabilities and retaining walls to withstand tsunamis of 5.7 meters. The tsunami which hit Fukushima reached a height of 15 meters. The events that led up to the Chernobyl disaster were started with a routine test on the plant's response to blackout conditions, during which the emergency safety and power regulating systems were shut off. However, the test diverted from routine when the operators neglected to follow their checklist for the test procedure. They arranged their core counter to the instructions given, which compounded a known design flaw when a power surge hit the unprotected system. Had the operators followed their checklist, the system likely would have behaved as expected. The 3 Mile Island accident was caused by a failure in the heat transfer side of the system. This is the non-nuclear portion of the plant, where water is converted to steam to run the turbine. This was followed by a stuck-open relief valve in the nuclear system, allowing considerable amounts of reactor coolant to escape. These are both conditions which are preventable and should have been spotted by the plant operators during routine shutdowns for inspection. You may notice a trend with the causes of all these accidents, that they all seem to stem from a human dropping the ball in maintaining the equipment. That is why, in the years since those accidents, training for operators has improved faster than ever, with the focus squarely on safety. There is obviously room for improvement, especially in standardizing worldwide, but it's time to stop letting these disasters hold us back. The reality is, access to electricity is the deciding factor in your quality of life in 2019. It determines your level of health care, your ability to feed yourself, your access to clean water, your ability to educate yourself, and so many other things. Nuclear power is the legacy of Dr. Oppenheimer, who, by becoming death, joined the ranks of Prometheus to give us the ability to unlock the energy of the sun. There are those among us who want you to believe that it is inherently dangerous and will surely be the destruction of the Western world. This is simply one more way that we remain caught in a social hierarchy where people who are tired, poor, and hungry are seen as lesser life forms. Through embracing nuclear power technology, we could advance the improvement of even safer reactors, such as molten salt reactors. These reactors use fissionable material, which, in salt form, is much more readily available closer to the surface when mining. These reactors also give us access to using materials such as thorium, which fission much more readily themselves, thus being a much better fuel. For more information about that, I strongly recommend the video by Dr. Kirk Sorensen, which I will link in the description. Well, those are my thoughts on that. And if you stuck with me this far, please like and subscribe. For now, I'm the X-Acto Guru, reminding you to be excellent to each other.